Hello students, in this today's video's lecture we'll start with engineering graphics, subject called engineering graphics, or the other name is engineering drawing. Why these two names? Before we used to call it as engineering drawing, now there is a term existence as engineering graphics. What is the difference between these two? Coming to engineering drawing, to draw any object or any component or any of the layouts, we used to have a drafter, then all the drawing instruments under existence. Okay, a drafts person used to use a drafter and draw all the drawing instruments, a table, then the whole setup will be there to draw any of the components views. Fine. Now there is a term existing is engineering graphics, which is all about, now we are eliminating this drafter, drawing instruments, tables. With this, graphics is all about software. For example, AutoCAD is one example where whatever the work or whatever the drawing you perform on a table by using a drawing sheet and all the drawing instruments and drafter, that can be eliminated by using a software called AutoCAD. The basic software, drafting software, what we call is AutoCAD. Okay. Where in this software you can draw whatever the views you want accordingly on a sheet of paper which is there in the software. Same thing can be taken as a hard copy print. They are using engineering graphics. The name they are using is engineering graphics. Accordingly, they are using a software lab also, where they are trying to perform or they are trying to draw all the views of a component by using a software, not by the traditional way. This we can call it as, this method we can call it as a traditional method, traditional way of drawing. Okay. Now this is no more existing. Few colleges are still under usage of this process, and most of the colleges are under usage of graphics, where they are using some softwares. What is the advantage of doing this? Why we are shifting from engineering drawing to engineering graphics, where most of the students or engineers won't have hands-on experience of using a drafter. We'll see that. Okay. As this is all about introduction to engineering graphics or engineering drawing. Okay, fine. If you take engineering drawing, here we use drafter, drawing instruments, everything. Once the drawing is developed and it has been sent to the shop floor for manufacturing, if you find any difficulty, if the person who is going to manufacture find any difficulty, in such cases the sheet will come back again to the design department or to the person who got drafted it. So then what happens? There we need to do some editing, which in this case by using a drawing sheet may be a tedious task. You need to erase, you need to work on, or else in general, industrially if you will take, there will be a draft sheet followed by bottom table. Now this table will talk about the company name, component you are going to draft, the person who drafted it, the day, time, date, everything will be provided here, followed by whatever the sketch you make with all the specifications, tolerances. Fine. Now if the same sheet has come back from the shop floor, then the table, there will be a table which will give you the revised dates. For example, this is made on some date, some X date, 1st of April, 1st of March for example. Then the next date may be 5th of March. If you edit the sheet, that date has to be specified saying that it has been edited for so and so reasons, and some other, for example, it again come back to the design department for the second time for editing, maybe that date will come here. So if you keep on edit the drawing sheet, there may be it may get spoiled. You can't erase all the time, or you can't make changes on a single sheet all the time. You need to take a new fresh sheet, which is time taking process. That is the main problem with engineering drawing. Okay, so main thing is editing is problem, and storage again is a bit problem, because sheets you can't store it for years together, which is a problem again. If you fold the sheet, if you roll the sheet, if you place it in some right storage place also, after a few months or days it may get spoiled. That is the reason traditional way of using these drawing sheets and all, they used to work on blueprints. They used to make a blueprint of whatever the drawing they made on a draft sheet. For preserving purpose, they used to print on a cloth. In some cases they used to print on a cloth also for proper preserving purpose. So this we can eliminate, storage we can eliminate, editing we can eliminate by using engineering graphics, which is very much easy to store because you have a very big database where you can store all your models, and editing is a very easiest thing where you can retrieve the component from the database, you can edit wherever required, and you can feed it back to the system, which is a easiest task. That is the reason. So here in this case, storage easy, second one, and you can retrieve it by its name, maybe name of the sheet, you can retrieve it back from the database. You have a very big database in this case, fine. That is the reason we are shifting, at the level of engineering only, in college days only, we are shifting from drawing to some graphics. Most of the colleges has divided their semester into two. One, they have to learn the traditional way, they have to learn what you call software method of using drawing also, that is also more important. So they are splitting the semester into two, that is also there under existence, fine. Similarly, you have now what is the syllabus we are going to cover, what is the type of syllabus we have, okay, what actually drawing is all about, why we require in engineering practice. So in simple way I'll tell you, engineering graphics or engineering drawing is used to communicate other person, and other person should be an engineer again, without which you won't understand, fine. Other person should be an engineer, fine. So communicate, the word communication indicates that no need to write any descriptive part of some X component, simply drawing is enough, an engineer can only understand. So simply we can call it as, what is engineering drawing? It is a language of an engineer. We can call it as a language of an engineer can only understand some X drawing made by some other engineer, maybe universally acceptable. If an Indian drawn a sketch by using first angle projection or third angle projection, that is sent to some other states, fine, maybe Germany, some other western countries, they can only understand, they will understand, if he or she is an engineer, they'll easily understand the drawing whichever sent to them, fine, basing on the dimensions or the views, whether it is a first angle projection or third angle projection. That all we are going to discuss in the upcoming series of lectures. Here this is all about introduction. Students will have a dilemma that why we are learning so and so drawing subject in the first year. Most of them are in a very big dilemma. That is the reason I am making it so clear in the introduction part, that this is a language of an engineer to communicate another engineer, fine. In this engineering graphics or a drawing, we are going to learn about, for example, regular polygons. We are going to learn about regular polygons, okay. For example, maybe a hexagon, okay, maybe a pentagon, maybe a square, similarly octagon, heptagon, many other, fine. Accordingly, how to draw these sketches we'll try to learn in regular polygons with respect to their angle, with respect to the horizontal, fine. Similarly, we are also going to learn about cycloidal curves, okay. We are also going to learn involutes, circular involutes, square involutes, fine. So all these topics we are going to cover in the upcoming series of lectures of engineering drawing or graphics, fine. These are all the topics we are going to cover, basic topics. Other than this, you have one more topic called scales, fine. So in this scales, what we are going to learn, scales are of three types, 1, 2, 3, for example, of regular size, enlarged size and reduced size. You can call it as regular size means whatever the dimensions given in the question, accordingly we will try to draw. We don't make any changes in the dimensions, okay. Whereas in case of enlarged scale, what happens, for example, you need to place a very big structure, building structure on your A3 size drawing sheet, which is a 10-floor building, maybe a 20-floor building, which is not at all possible to place. In that such cases, what we try to do, we'll try to go with a reduced scale, fine. In case of reduced scale, what we try to do, buildings can be reduced, okay, the sizes can be reduced by taking 1:2 ratio, or else 1:3, or else 1:4 ratio. We'll try to scale down the complete dimensions and we'll try to represent that particular scale on the bottom right corner of your drawing sheet. Whereas in case of enlarged scale, what we try to do, the best example is, you can take your wristwatch. The wristwatch contains numbers, dials, okay, that is not visible from some distance. So that can be drawn by enlarged view, which is 1:2:1, 3:1, 5:1 or 10:1, or 15:1. You can enlarge the way you want to place it on your drawing sheet. Fine. So similarly, cycloidal curves are of types like epicycloid, hypocycloid and cycloid. So what is a cycloid means? When there is a linear distance. Now when there is a circle, for example, a circle travels linearly. The start, for example, if this I'll take as a reference point, if this reference point rolls 360 degrees and touches this linear line somewhere, exactly somewhere away from the reference point, that point is from the starting point till the end point will get a curve. That curve we call it as a cycloidal curve. Similarly, if the same circle rolls on another circle, for example, something like this. If the same circle rolls on another circle with respect to this reference point, okay, wherever it touches with the directing circle, onto the directing circle, that curve we call it as epicycloid. Similarly, hypocycloid means there will be a directing circle and a same circle again rolling under or inside a directing circle. This we call it as directing circle. This is generating circle. If this rolls inside another circle, then if you take this as the reference point, will come touch after 360 degrees rotation, come touch the directing circle somewhere to develop a cycloidal curve, okay, which is hypocycloid. So this is the difference between cycloid, epicycloid, hypocycloid. Similarly, involutes, you have square involute, you have circular involute, square involute, triangular involute, pentagonal involute, many more. That all we will discuss in the upcoming series of lectures. Other than this, one more important topic, projections. The most important one is, which will talk completely about engineering graphics or engineering drawing, which is number 5, projections. In these projections we have many types. For example, projection of SWOT, projection of points, projection of lines, again projection of planes, similarly solids and section of solids, maybe the development of solids. You also going to learn about isometric orthographic views, conversion of ISO to ortho to ISO. All these things you are going to learn, and other than this you may also learn about perspective projections. Fine, you are going to learn all these topics in engineering graphics. Okay, what are projections means? What are projections? For example, if it is a point or a line, so you have two types, projection and a projector line and a projection line. So we are going to learn about projections, where we are going to learn about views of some x component. Fine, views of some x component. In general, we will consider 4 quadrant system: first quadrant, second quadrant, third quadrant and fourth quadrant. Okay. Consider this as a vertical plane, this as a horizontal plane. Plane, we call it as this line as a plane because it is completely aligned, normal to the person observing. That is the reason we could see a straight line. If I try to enlarge it, if I try to make a 3D model, the model will be something like this. Okay, the intersection of these two is nothing but your xy line. Now here we try to deal with all the 4 quadrants in case of projection of points. Okay, straight away I'll start with projection of points in my next lecture. Fine. Now in the projection of point, what we try to learn, we'll try to place an object somewhere in first quadrant and we'll try to represent it from front and top. Similarly, in second quadrant, we'll try to represent it from front and top. Similarly, in third and fourth quadrant also. After that, again we'll deal with the same concept. We deal with projection of lines, projection of planes and solids. When it comes to lines, planes and solids, we only deal with first angle and third angle, not with second and fourth angle projections, because in case of second and fourth angle, the objects, the views will overlap with each other. Front and top view will overlap with each other in these two cases. That is the reason we will try to eliminate second and fourth from lines. Fine, we use only first angle and third angle projections. So in the upcoming lectures, we are going to learn about all the projections. My first lecture in engineering graphics going to start with projection of points. I'm going to start with projection of points. Fine, very much easy, very much important for an engineer, whether he is a mechanical engineer or any IT, any civil engineer. This is most important syllabus I'm going to cover. Try to concentrate more on upcoming series of lectures, and also you can find the link below in the description. If you click there, you find many more topics, upcoming topics. You can click the link description below. Thank you for watching.